Well, welcome everybody. I'm just going to make a small video here about the solution to test 3. So problem 1, you have these 4 choices, A, B, C, D. Now, if we look at this guy's got a horizontal asymptote like -4, so it suggests it's that one, so that's why I put B here. Let's see here. This one looks like a natural log, shifted over a little bit, so that's that one, C. 3 to the x plus 1 should have a horizontal asymptote of 1 and look kind of like D, so there's D, and that leaves us with A, must be the other one. So there's that. Now, moving on here. Problem 2, the usual thing, so we write down y equals the formula, and then we solve for x. So what I did was I multiplied by the denominator 3 minus x, and so you get y times 3 minus x, 1 times 3 minus x is 3 minus x, and then we got 2x plus 7. Then I distributed, so I get 3y minus xy equals to 3 plus 7, which is 10, and then x minus 2x is x. I brought all the things with x to the same side, so that gives me xy plus x equals to 3y minus 10. Factored out the x, and then divided by that. Y plus 1 to give me x is 3y minus 10 over y plus 1, which gives me the formula for f inverse of y is 3y minus 10 over y plus 1. So that was problem 2. Now, I have not graded these, so I don't know how you guys did. And if I've made some stupid mistake in this solution, my apologies. I'll find out when I grade. Because if, like, a bunch of you have a different answer than I do, probably I'm wrong. So we'll find out about that. But hopefully this is right. So then next problem, we have 2 graphs were given. And let's see here. So this one can't be invertible because it fails the horizontal line test. Not invertible. This one passes the horizontal line test, but so what I did was I just picked some points and flipped them. Like the point -4, -2, I flipped to, rather -2, -4, I flipped to -4 to -2. And this one I flipped from 4, 8 to 8, 4, and then connect the dots. There's your inverse graph. Problem 4. Let's see here. I exponentiated both sides, base 2. So that killed off the log base 2, gave me x minus 10 equals 2 to the 3rd power, which is 8, which gives me x equals to 18. The next problem, I used the 1-to-1 property. 100 is 10 squared, which is 10 to the 2. So then by the 1-to-1 property, I get x squared plus 1 equals to 2, which gives me x squared equals to 1, subtracting 1 from both sides. So then take the square root of both sides, plus or minus, of course, square root property. You get x is plus or minus 1. And there's that one. Problem 6, we take the natural log of that equation. There's other ways to do this, but that's how I did it. Take the natural log of both sides. That pulls down log 3 on the left-hand side, log 2 on the right-hand side. And then I get x times the difference of log 3 and log 2. But that's a non-zero number. X times a non-zero number equal to 0, therefore x must be 0. X equal to 0 is the solution there. That's that. Let's see here, moving along. Problem 7. Problem 7. Here's that one. So we've got natural log of, well, we've got 2 natural log of x plus 1/2 log of y plus 1 minus log z. And so here I put the x squared for log and then multiply by the square root of y plus 1 because that 1/2. And we divide by z because we got subtraction to z. On the board, I told you guys that we could change this one to make it easier. So I just made a equal to log x, I can't spell, b log y, and c log z, right? So with respect to that, we get 3a, 3 plus a plus 1/2 b minus 3c. Now, let's see here. Furthermore, the next problem, what I do? I divided by 3, which gave me 1/3. Then I put the third into the cube root, so I've got log base 4 of a plus 3b equals to log base 4 of the cube root of c. And then 1-to-1 property for log base 4 gives me this. And then subtract 3b to the other side. There's your solution. So that was kind of similar to a problem in the mission. This might have just been, this might literally be a problem in the mission. Sorry, I do try to change the numbers. I might have forgot this time. So 6 is equal to 5 plus 2 e to the minus 3t. So I subtract 5 to the other side. I get a 6 minus 5, which is 1. Then I divide by 2, gives me 1/2 is the exponential to the minus 0.3t. Take the natural log of both sides. We get natural log of the exponential, which just spits back out minus 0.3t. Divide by minus 0.3 into the log of 1/2, and we get 2.310 approximately. That's the solution there. Finally, last page here, we have, and I will scan this and post it in Canvas if I haven't already. I don't think I did yet. So here we've got the natural log of the product of x minus 1 and x plus 1, because sum of the natural logs is the log of the product, and that equals log 3. I exponentiate both sides, and that gives me x squared minus 1 equal to 3. Add 1 over to the right-hand side, I get x squared equals to 4. Square root property gives me x is plus or minus root 4, which either gives me 2 or minus 2, but minus 2 doesn't work, because if we plug minus 2 back into the original problem, we get logs of negative numbers, which are not allowed. And so then that brings us to the next problem here. So there's just one solution up here, x equal to 2. The other one was extraneous. Problem 12, it's another one of these quadratic exponential problems. So we recognize 2 to the x squared minus 2 to the x minus 2. If we let y equal 2 to the x, that gives us y squared minus y minus 2, which factors to y minus 2, y plus 1, which either gives us y equals 2 or y equals minus 1, which means we're either up against 2 to the x equal to 2 or 2 to the x equal to minus 1, but 2 to the x equal to minus 1 is impossible. So we just get a solution there. Of course, 2 to the x is equal to 2 is the same as 2 is 2 to the 1, right? So by 1-to-1 property, we get x equals to 1 is the solution there. And final problem. Supposed to find the formula for the inverse function and find the range, given that f of x is 3 plus 10 e to the 2x minus 7 here. And so what I do, write down the formula, subtract 3 to the other side, divide by 10, take the natural log of the equation, and simplify. So that natural log of the exponential gives me the argument 2x minus 7, because these are inverse functions, they cancel. And so lo and behold, we solve for x, 7/2 plus 1/2 natural log of y minus 3 over 10, and there's your formula. And I see I have forgot to answer the question. So find the range. What's the range here? Well, the range of the function is the what? Try to sit down here and see if I can. The way I've got this camera situated, it's hard for me to write. Give me a second here. So we need y minus 3 greater than 0 to make that formula make sense. And so that means that the domain of f inverse is 3 to infinity, right? And so that's the range of the function as well. All right. Hope I don't know if you guys can see what I was writing. I'll put it in frame now here. Sorry about that. So yeah, to figure out the domain of the inverse function, we just look for where the natural log has a positive input, which would mean y minus 3 has got to be greater than 0, which has solution y greater than 3. So 3 to infinity is the domain of the inverse function, which is the range of the function. So 3 to infinity was the answer to that part. And there's the formula for the inverse function. Well, I hope that makes sense. And Monday we'll meet back again in person. As far as I know, there's no football game Monday, so we should be good to go. Have a good weekend, you guys. Thanks.